So we're ready for section 1.5, and we're finally getting into solving linear equations. So the first thing is, if we're talking about equations, these have equal signs. And I think it's important to realize that solving actually means something. The word solve means to find a value for a variable, usually x, that will make the equation true. Now this is my definition. In a different book, or if a glossary or a dictionary might explain a little bit differently. But as I look at the next slide that has several problems, they'll each have a variable in it. They'll each be equations, so they'll each have equal signs in it. And we're going to find a value or a number that when we replace it in for that variable, it will satisfy the equation. Just a few little things. Just make sure you know that you do the same operation on both sides of the equation. You probably remember that from Algebra 1, Algebra 2, etc., etc. Just like if you add 8 to the left side of the equal sign, you have to add 8 to the other side. So the one thing I like to point out to students is usually you can just do the order of operations backwards. For instance, I know this can confuse students, so I apologize if this is confusing to you, but most of you are probably familiar with this anyway, is if we knew what x is, let's say x was 10, well, would you multiply by 3 first or add 7 first? I think you'd all know that you'd multiply by 3 and then you add 7. So to undo this, to do the order of operations backwards, you want to subtract 7 to the other side. And maybe I should point out where your equal sign is. Like right there is your equal sign. So you have the left side and the right side. So as you subtract 7 over, it'll cancel this piece out. And you're left with 3x is equal to 22 minus 7 is 15. And now you want to do the inverse of multiplication. Well, the inverse of multiplication is division, so you divide by 3 on both sides. Again, it's worth noting that your equal sign is still here, so then you could cancel out your 3's. 15 divided by 3 gives you x equals 5. Now before moving on, I want to point out that you can check your work, put a little check mark in here, that if you plug 5 in for x, well, 3 times 5 is 15, and when you add 7 to it, it equals 22. This value makes that equation true. All right, moving on to the second example, really the same thing. I don't know if this order of operations helps you or if you just remember doing this from before. But we throw in some decimals for you. The first step is to subtract 2 to the left side. Well, 0.6 minus 2 is negative 1.4. It's equal to negative 3.5. See, if you don't believe me, feel free to use a calculator. Now you could type in 0.6 minus 2 equals negative 1.4. And then, oh, that was supposed to say C. And then, this is a multiplication problem, so to divide is how to get rid of the multiplication. So divide both sides by negative 3.5. And again, with the calculator, because you're allowed to use it, just divide by negative 3.5. And you get your answer of 0.4. Sorry, I didn't give you much room. Alright, and you can double check that this is correct by plugging it into C right here. Double check that you have the correct answer. And I'm not going to waste your time doing that. I would just encourage you to do that. Moving on to the next problem. Before adding and subtracting terms on either side of the equation, I would suggest to simplify first. That means combining like terms. So I'm looking at negative 8x and 6x are like terms on the left side. So I would rewrite this equation as negative 2x because you combine those first, and then we can worry about getting like terms on the same side. So 5x minus 4x, that is 1x. This is why we teach you all those other things before getting into this unit. Sorry, my ones kind of went together, 11. Now I would get my x's on the left side first, so I would subtract 1x to the left side. So that cancels. Negative 2x minus 1x is negative 3x. Minus 4 is equal to 11 now. So now I can add 4 to the right side. Kind of running out of room, so I'm just going to go right here. Negative 3x. These cancel, equals 15. And then I can divide both sides by negative 3. And again, I'm running out of room, so I'll just go ahead and write that x equals negative 5. So that's your answer to exercise 3. Maybe it's a good time to point out a little trick with your calculator is you can plug into your calculator. This would be a long one to show you with. Maybe I'll just move on to the next one. Don't forget you can plug in these values for all of these x's, and the left side will equal the right side. The next one, again, I would simplify first, and you simplify by distributing. So we're at 3x minus 15 is equal to 6x minus 3. And maybe this time I'll show you that you can do 2 steps at once. For instance, I can subtract 6x to the left side. If you remember, that was my preference on getting x's to the left side. And I can add 15 to the right side. That way I'm getting my x's together, and I get negative 3x on the left side. And I'm getting my constants together on the right side, is 12. And divide both sides by negative 3, and I'll get x equals negative 4. So what I'm going to do is show you a trick with a calculator now, because this isn't as daunting of a question, is you can actually use this store key in your calculator and just type in negative 4, and I'm going to store that in for x. So what I'm doing by pressing those keys is anytime I push x into the calculator now, it's equal to negative 4. If I were to write 2x, it's negative 8, because 2 times negative 4 is negative 8. So the reason why I'm showing you that trick is now I can kind of just type it in, 3 times x minus 5. And here's a neat trick for you, is under the math tool, there's this test key. And if I hit second math, I can test if the equation is equal to 6x minus 3. Now your calculator doesn't say yes or no, this is a true statement or not. What it does is it says 1 or 0. 1 means yes, this is true, and 0 means no, this is false. And as I click enter, it says 1 because it's a true statement. So if you have a graphing calculator, this is a neat way to test that your answer is correct. And some of you may have wished you had it for, I don't know, a previous math class. Let me move on to the next one. Notice I changed my variables, but that's not a big deal. I know some people strongly dislike fractions. So I can show you how to get rid of fractions, and that is getting the least common multiple between 2, 5, and 4. The least common multiple of all these numbers is 20. So I can multiply all of these values by 20. Well, 20 divided by 2 is 10y. 20 divided by 5 is 4y. Is equal to 20 divided by 4 is 5. So now that I'm looking at that, I can combine like terms. So 6y is equal to 5. And I like fractions. 5 divided by 6 does not equal anything special, so we can just leave it as 5, 6. All right. I'm going to use the same trick for exercise 6, because we have all these fractions, and I know some people don't like fractions. But the least common multiple between all of those is 12. Now you have to be careful here. So 12 times x is 12x. I hope I'm not confusing you by not putting like 2 12s in here. I am multiplying to both sides. I guess I didn't show my work here. And then the 12 divided by 12 will cancel each other out. But there's an implied parenthesis in the numerator. Why am I pointing that out to you? Is because you technically need to distribute that in there. So this is really 12x minus x, which is 11x, but it becomes plus 2 on that problem. Same thing with this. As I plug this in, 12 divided by 4 is 3, but you have implied parentheses in the numerator. And 12 divided by 4 is 3. You have to distribute. So as I look at this, I have 3x. 3 times 3 is 9, plus this 3 is 12. So now as I get 3x to the left side, and subtract 2 over here, so I'm down to 8x is equal to 10. And you can see that I'm showing less work as I go. And if you divide both sides by 8, you can reduce 10/8 to be 5/4. As a reminder from Algebra 2, I hope you learned this in Algebra 2 or earlier, that you can divide both top and bottom by 2 to get that new fraction. All right. Just the last 3 examples here. I have plenty of time to get through this. They're just throwing more fractions at you. But as long as you can identify where your equal sign is, get your x's to the left side, and you can use a calculator, don't be scared by this problem. To get negative to the other side, you add it. So these both cancel. 0.15 minus 0.2 gives me negative 0.05. And adding that gives me 0.15. And divide both sides by negative 0.05. And positive over negative is a negative, should be 3. Okay, so we do have a few other items that we need to discuss. So hopefully you didn't get too far ahead of me. Is as I distribute this, again, I like to simplify before doing things. So nothing to simplify on the left side. 4x plus 20. But as I subtract 4x over here, what you'll notice is both terms cancel. So I'm left with negative 3 is equal to 20. Well, if you look at that, there's no variables now. And this is not a true statement. So this is no solution. So what does that mean? That means there is no possible value for x that makes this equation true. And if you get a graphing calculator out, what you can do is type them into this y equals, sorry, I had a previous problem in there, 4x minus 3, and then 4 times the quantity of x plus 5. And let me just get my graph. What you notice is that these two lines will never cross. You might be looking at those and say, oh, well, what if you zoom out? I could zoom out, sure. And they're still not crossing. And the real answer is that they're parallel. And that should make sense that they're parallel, because in Algebra 1 or geometry, you learn that if you have the same slope but different y-intercepts, then they're parallel. Well, if they're parallel, those two lines will never cross, which means there's no possible values for x to make this equation true. Now we have another situation. Again, you need to simplify for this one. 5x minus 2 is equal to 3 plus 5x minus 5. And then as you combine those on the left side, 5x minus 2. And maybe this time, some of you might stop right there. But what you'll get is negative 2 is equal to negative 2. Well, we've gotten rid of all of our x's. And basically what it boils down to is we have a true statement. This means that there is an infinitely many solutions. So like up here was a false statement. So there is no solution. Well, this was a true statement. Negative 2 always equals negative 2. So there's infinitely many solutions. That means every answer for x works. Pick a value. It'll work for x. It'll make that equation true. You might see all reals written in the book. All real values for x makes the equation true. There's another name that we use for these two things. We call the example 8 an inconsistent answer, and we call this one in number 9 an identity. All right. So now you're ready for the homework. Notice these are multiples of 4, so we're talking like 4, 8, 12, etc.